sklearnmetricsDetCurveDisplay. Description: the DetCurveDisplay class provides a way to visualize the detection error trait of DetCurve. The DetCurve is a graphical representation of the performance of a binary classifier. It plots the false positive rate FPR against the false negative rate FNR. Or equivalently, the true positive rate TPR against the false positive rate FPR. Inputs: estimator: a fitted estimator object that implements the predict_proba method. This method is used to obtain the predicted probabilities for each class. X: the input features for which predictions will be made. Y: true: the true labels for the data. Poslabel: the label of the positive class. Outputs: figure: a matplotlib figure object containing the DetCurve plot. Ax: a matplotlib axis object containing the DetCurve plot. Steps: calculate the predicted probabilities for each class using the estimator's predict_proba method. Calculate the FPR, FNR, TPR, and FPR based on the predicted probabilities and the true labels. Plot the DetCurve using the calculated FPR and FNR values. Metrics: false positive rate FPR: the proportion of negative samples that are incorrectly classified as positive. False negative rate FNR: the proportion of positive samples that are incorrectly classified as negative. True positive rate TPR: the proportion of positive samples that are correctly classified as positive. True negative rate TNR: the proportion of negative samples that are correctly classified as negative. Visualization plots: DetCurve: a plot showing the trade-off between the false positive rate FPR and the false negative rate FNR. Fine-tune parameters. Poslabel: the label of the positive class. This can be used to specify the class that is considered positive. Uncertainty methods. Confidence intervals: the confidence intervals for the FPR and FNR values can be calculated and visualized on the DetCurve. This can be used to quantify the uncertainty in the performance estimates. Bootstrap resampling: bootstrap resampling can be used to generate multiple DetCurves and assess the variability of the performance estimates. Challenges and fixes. Challenge 1: imbalanced datasets. Sample use case that resulted in challenge 1: when the dataset has a large imbalance between positive and negative samples. The DetCurve may be skewed and difficult to interpret. Fixes to challenge 1: use appropriate sampling techniques like oversampling or undersampling to balance the dataset before training the classifier. Challenge 2: non-informative DetCurve. Sample use case that resulted in challenge 2: when the classifier performs poorly. The DetCurve may be a straight line, indicating that the classifier is not able to discriminate between positive and negative samples. Fixes to challenge 2: consider trying different classifiers, adjusting the hyperparameters of the classifier, or adding more features to the dataset.